Looking here at number 10, I am going to utilize the ratio test. Start with since x minus 1 to the n plus 1th power, so I'm writing out here the n plus 1th term over n plus 1 of the series that I'm interested in. I'm going to divide that by the nth term, x minus 1 to the n over the square root of n. And I'm going to examine that in the limit as n goes to infinity with absolute values around it. Okay, so simplifying a little bit, I have the limit as n goes to infinity. The things involving n, square root of n, the numerator, flipping that guy upside down, and then the square root of n plus 1, the denominator, and then x minus 1. And thinking about putting parentheses here, but actually I could put my absolute value symbol there, since square root of n over square root of n plus 1 is always positive. Let's see. That, in turn, is, well, I've dealt with this kind of limit before. I could divide the numerator by square root of n and the denominator by square root of n. The limit of this ratio is simply 1. And x minus 1 doesn't go anywhere as n changes, so that's the value of the limit, and I'll say that that's less than 1 when x is, well, x minus 1 needs to be between 1 and negative 1. And that inequality, system of inequalities I should say, is equivalent to, let's see, I will add 1 over here, and that would bring me to 0, less than x, and then add 1 over there, and I'd get 2. Okay, so I'm going to get absolute convergence of this sequence, rather of the series that I'm looking at for these x values. And I can already see the radius of convergence, but I need to look at the endpoints. And let me take a look at the endpoints here. So 0. I'm going to put in 0 for x in a series that I'm examining. That will be 0 minus 1 to the n over the square root of n. Now that is a convergent alternating series. While examining the other endpoint when x is 2, the sum equals 0 to infinity of 2 minus 1 to the n over square root of n is a divergent p-series. Okay, so this is the p-series with p being 1/2. Putting all of this together, I can talk about the series. Sum n equals 0 to infinity x minus 1 over square root of n to the nth power. And I can say a variety of things, all the things that are requested. First off, find the series radius and interval of convergence. Has radius of convergence. Okay, so looking at this interval here, the biggest value is 2, subtract the smallest value 1, and divide by 2. The radius is 1. Good, that is the radius of this ball, if you will, around 1. This power series centered at 1. So 1 plus 1 to 1 minus 1, everybody inside of there gives an x value for which this thing will be convergent. And interval of convergence. So it's going to be the interval 0 to 2, but I need to decide if 0 and 2 are in there. 0 is in there because we found we get a convergent sequence when we put in 0. We get a converging alternating sequence. While when we put in 2, we got a divergent p-series. So that, not including 2. Okay. B, we're looking for where this converges absolutely. Well, this series is the same as this series if we take the absolute value of every term. So that is to say, this series does not converge absolutely. Right? So we do not converge absolutely at 0. And we will say converges absolutely on the interval 0 to 2, not including 0 and not including 2. So the ratio test here showed where we had absolute convergence, and we found that we did not have absolute convergence at either of the endpoints, at 0 or at 2, because putting in 0 or 2 and using the absolute value of the terms both gives the divergent p-series. Right? Sum from n equals 0 to infinity of I just realized that I made a few typos. I like starting at 0, but in this case, that's not what I was supposed to copy from the book. I was supposed to start at 1, which is a good thing, because now I'm not dividing by 0. At any rate, converges absolutely on 0 to 2, because at both of the endpoints, if we use the absolute value of these terms, we get divergence. Okay. So that is where the series converges absolutely. And C, converges conditionally. We found that we get convergence at 0 here. Right, that's a convergent alternating series, but if we take absolute value of every term, we get the divergent p-series of p being 1/2. To finish this off, I'll say and nowhere else.